Hey guys, I'm Beth from my tutoring bee, and today we are going to be talking about Pythagorean theorem. So let's get started. So Pythagorean theorem is basically just a big fancy way to determine the length of each side of a right triangle. So this specifically has to do with right triangles. And a lot of times when we're dealing with Pythagorean theorem, we're given a right triangle, we're given this formula, a squared plus b squared plus equals c squared, and it's kind of confusing at first as to what all of that means. So I'd like to show you where all of these different variables go in relationship to the right triangle, and then we're going to start solving some right triangles after this. So we have this right triangle, and we can tell that it's a right triangle because of this little box indicator right here that this is the 90-degree angle. The two sides that create that 90-degree angle are going to be your A and B sides. It doesn't matter which one is A and which one is B. They can be switched, so we could label this one as B and this one as A instead, because A squared plus B squared, because of the commutative property, we can switch the order of numbers or variables that are being added. So that's why it doesn't really matter which one is A and which one is B. But you know that these two are the A and B sides because that's where that 90-degree angle little indicator is touching the two sides. It's the two sides that make up that 90-degree angle. And then the side that's opposite of that, you may have heard the word hypotenuse. That's what C will always be. C will always be the hypotenuse. This is also the longest side, always in a right triangle. So now let's get into some actual numbers and how the Pythagorean theorem works. So here we have a right triangle and we're given some side lengths. So we're just going to use the Pythagorean theorem to test out to see if this truly is a right triangle. So we first have to identify which sides are A, B, and C. Again, whatever two sides makes up that right angle, so the two sides that are touching this marker here, those are going to be our A and B sides. So we've got A and B. Again, I can switch those around if I want to. So then that means that 5 is going to be our C. And we can also tell that 5 has to be C because it's the longest side out of the three. So now we simply need to just plug those in and solve to see if it does truly make a right triangle. So A is 4, so we're going to plug in 4 squared. B is 3, that's 3 squared. We're going to add those two, and then it should equal C squared, which is 5 squared. So 4 squared, be careful with this. It's easy to see the 4 and the 2 and just to multiply 4 times 2. But remember that 4 squared means 4 times 4. So 4 times 4 is 16, plus 3 squared is 9, and then 5 squared is 25. And then when we add 16 and 9, that does give us 25. So 25 equals 25. So this is a right triangle. Let's try it on this triangle. Now this triangle doesn't give us the right angle indicator. We need to actually determine if this is a right triangle or not. So feel free to pause the video and try this on your own. Determine which sides are A, B, and C. Use the formula and see if it does make a right triangle or not, and then we'll go over it together. So my longest side I know needs to be C, and then the two shorter sides I'm going to label as A and B. And then we're just going to take those numbers and plug it into the formula. So A is 7, that's 7 squared, plus B is 6, that's going to be 6 squared, and C is 9, that's going to be 9 squared. Let's solve each of these. So 7 squared is 7 times 7, 49. 6 squared is 6 times 6, which is 36. And then 9 squared is 9 times 9, which is 81. All right, now let's add. What is 49 plus 36? 9 plus 6 is 15. 4 plus 1 plus 3 is 8, so we get 85. So does 85 equal 81? No, it doesn't. So this is not a right triangle. Okay, now we're going to look at a triangle that is missing a side length. We have to use the formula to determine what this missing side length is. We do know that it's a right triangle because of this symbol right here. And that means that these two sides, the 12 and the 5, are going to be our A sides and B sides. Okay, again, you could label the 12 as a B and the 5 as A. I'm going to label it this way. So now we're going to take what we know and plug it into the formula and then solve for C. So A is 12, so we're going to put in 12 squared here. B is 5, so we're going to write in 5 squared here. And then we don't know what C is yet, so we're just going to leave that as the variable C squared. But we can solve these two pieces. So 12 times 12 is 144. 5 times 5 is 25. And again, we're just going to drop down the C squared. We don't know what that is yet. We can add these two. 144 plus 25 is 169. It's totally okay to write it out to the side. That's fine. Don't be afraid to write out your work just to make sure that you've got it right. Okay, so now a lot of times what will happen with students who are new to this, I do private tutoring, so I work with a lot of students when they are trying to learn new concepts, and they'll get to this point and they'll say, oh, okay, 169, that's what this equals, is 169. But remember that that is C squared. We need to find out what just C is by itself. So we're actually going to take the square root of both of these numbers. So the square root is just the opposite of the exponent 2 that we've been doing all of this time. So we're trying to figure out what number times itself, so it has to be the same number, equals 169. Okay, so you might use a calculator for this. You might know that 13 times 13 is 169, or you might be able to guess and check until you get to that point. But the square root of 169 is 13, and then the square root of C squared would be just C. So then that is actually our answer for this missing side length. 13 units. Let's try another one with a missing side length. This time I can see that the right angle is here. So this 15 can either be my A or B side, but then that means that the question mark is going to be the other one of those two. And then 17 is going to be my C side. So this one's a little bit different than the last one that we did. Again, feel free to pause the video at any point to work any of this out, and then we can continue on together. So I'm going to plug in the information that I have. So A is 15, that's 15 squared. I don't know what B is yet, so I'm just going to leave that as B squared. And this all equals C squared, 17 squared. Sometimes what I see my students doing is they see the 15 and they see the 17, so they put those two together and then set that equal to B squared, but you can't do that. The A and the B sides squared has to be the two that are being added together, and those have to equal the longest side, the hypotenuse, the C side. So don't make this mistake of transposing the numbers. So let's go back to the problem that I have written out here and solve it. So 15 squared, you can use a calculator, you can write it out, is 225, plus B squared, I'm just going to drop down B squared, and then 17 squared, let's figure that part out, is 289. Okay, so we are still trying to solve for B. So B squared is here on the left-hand side of the equal sign. That means I need to work my way backwards in trying to figure out what B would equal by getting rid of all of these other numbers that are over on the left-hand side that are with B. So since 225 is being added to B, I want to subtract 225 from both sides. You have to keep the equation equal. So that cancels out over here on the left-hand side, leaving me with just b squared, and that equals 64. Okay? Now again, just like in the last problem, this isn't our final answer. We're not quite there yet. We still have one more step to do. We know that b squared equals 64, but we want to know what just b by itself equals. So that means we need to find the square root of both sides. Again, square root means what times itself equals 64. So something times something equals 64, and these have to be the same number. So in this case, it's 8. So b by itself equals 8, and so then that means that this mystery number is 8 units. Let's take a look at why the Pythagorean theorem works. Here I have a right triangle with the side lengths of 3, 4, and 5. And I have created these little grid squares that all have the same, you can see that the size of the squares themselves are the same. And I have created them so that this one is 3 by 3, this one is 4 by 4, and then this one I just have to rotate it a little bit so that it lines up flush with the side of the triangle. But this one is 5 by 5 units. And so when I line these up like this against the triangle, I can see that 3 squared, right, 3 times 3, or 3 rows of 3, however you want to look at it, 3 times 3, or 3 squared, equals 9. I have 9 units inside of this grid square. Same thing with the 4. 4 rows of 4, 4 times 4. If we square that 4, then that is going to give us a total of 16. And when we add those two together, the two smaller sides, 16 plus 9, we get 25. And then over here with this square, 5 times 5, or 5 rows of 5, does equal 25. So this will always work for your right triangles, but you must square each side first and then add the two shorter sides to see if it does equal the longest side, the hypotenuse. Thank you so much for watching. I hope that this video helped you learn more about Pythagorean theorem and how to use it. Please like and subscribe. And also there are some links in the description below with some practice on Pythagorean theorem for you to use on your own.